Lesson 6-5, Solve Inequalities Using Multiplication or Division. In this lesson, we're going to learn about solving inequalities using multiplication or division as the one step to undo the process. Solving inequalities using multiplication or division is similar to solving equations using multiplication or division, but there is one catch. Take a look at the solve and discuss it, and I'd like for you to try to solve this inequality right here and see if you get an answer that agrees with Alex or Hope. Come back and check your answer for discussion purposes. Easy enough, right? Taking the inequality negative 6x is greater than 24 and dividing both sides by negative 6 should give you the result x is greater than negative 4, right? Well, think about what that means. X being greater than negative 4 means that x could be, let's see, negative 2, which is bigger. 0 is bigger. 10, even that is bigger. So let's check any of those numbers that are bigger than negative 4 back in the original inequality. Negative 6x is greater than 24. And let's see if those solution possibilities here, if they hold true. So when I do that, I substitute in for x one of my values. And then I have to see, is this true? Negative 6 times negative 2 is a positive 12. Is positive 12 greater than 24? The answer is no. Well, what happens if I substitute 0 in place of x? So now I have negative 6 times 0 is greater than 24. Well, negative 6 times 0 is 0. Is 0 greater than 24? The answer again is no. So what if I try a bigger number, like 10? Surely that's going to work. Well, negative 6 times 10 is negative 60. And is negative 60 ever bigger than 24? Again, the answer is no. So then you must be thinking to yourself, well, what gives? Because this is the answer that Alex got. So why would Hope's answer be correct? Well, when you take a look at the possibilities for solutions in Hope's answer, x is less than negative 4, then that means you're going in the negative direction even further, such as negative 5, maybe negative 10, or maybe even negative 20. And when you check those answers, negative 6 times negative 5, is that greater than 24? That's 30. And 30 is bigger than 24. That one checks out. So what if I substitute in place of the x a negative 10? Is that answer going to be bigger than 24? Yes, because negative 6 times negative 10 is a positive 60, and positive 60 is again greater than 24. And if I check the negative 20, that also does work, because negative 6 times negative 20 would be a positive 120, and that is definitely bigger than 24. So when we solve inequalities that involve multiplication or division, we have to be cautious of the inequality sign. In just a moment, we'll take a look at some more examples in order to decide how we can determine when this inequality sign in our work needs to flip around. Now let's take a look at example 1. Solve inequalities that involve multiplication or division of positive values. Gina's pot-bellied pig is on a diet. He can have no more than 18 ounces of pig food per day. How many scoops of pig food can Gina feed the pig without going over 18 ounces? So what we see here is that each scoop is a 4-ounce scoop. So she has 4 ounces times the number of scoops, and that has to be no more than 18. In other words, less than or equal. Okay, it could be 18, it can't be over 18. So step 2 is to go ahead and solve the inequality, which you can see that they did right here. 4s is less than or equal to 18. We're going to divide both sides by 4, and 18 divided by 4 gives us an answer of 4 and 5/10. So on the graph, notice that they found the 4 and 5/10 between the positive 4 and the positive 5. And we're looking at all the answers that are less than or equal to that. So you'll notice that there is a colored in circle there. That's the or equal to part. And you'll also notice, let me change colors here so you can see this better. You'll also notice that the shading here goes to your left. Okay. So then we need to decide, is that the correct solution? And the way you check your answers in an inequality is to substitute back into the original problem. So 4s is less than or equal to 18, a number that seems to fit what you just got for your solution, which is less than or equal to 4.5. So you don't even have to use the halves. Let's pick one of the whole numbers that is less than or equal to 4.5, like 3. So if I did 4 times 3, is that number less than or equal to 18? And the answer is yes. It's 12, and 12 is definitely less than 18. Okay? What if I picked another number, such as 1? Is 4 times 1 less than or equal to 18? And the answer is yes, because 4 is less than or equal to 18. So it seems that the numbers that fit the description here, 3 specifically and 1 that are underneath that arrow shading part, do work, which means Gina can feed her pig up to, but not over, 4.5 scoops of food. So 4.5 scoops or less. All right, now I'd like for you to try the try it question here at the bottom of the page. Come back and check your answer as soon as you're finished. All right, take a look at your solution to the try it. It is a division inequality, so you're going to solve that by multiplying both sides of the inequality by 7. And your answer is D is greater than 105. Now the way you check yourself is to go ahead and pick a value that is bigger than 105, divide it by 7, and see if the answer is greater than 15. Notice that the inequality sign is a greater than sign, so our circle on the graph here is an open circle. All right, I picked 106 because it's bigger than 105, and I divided it by 7 to see if that were greater than 15. 106 divided by 7 is not a whole number. It is a decimal, and it does repeat, but you can see even just with 1 decimal place or 2 decimal places that it is still bigger than 15 as a whole number, so that does check out. Then I can try another number. Let's say 120. Oops. So 120 divided by 7, is that greater than 15? Well, again, check it out by using your calculator. 120 divided by 15 is, let's see there, 17 and 0.1428571 and so forth. So I get that same 114 as the 2 digits after, but you can still see that that is greater than 15 without a doubt. So that does check out as well. So what we know is that we've shaded our solution set on the number line going in the correct direction. So now I want you to take a look at the convince me. It says Frances solved the inequality 5g is greater than or equal to 35. And she says that 7 is a solution to the inequality. Is she correct? And we're to explain. Well, when you solve this inequality, you do divide both sides by 5. So g should be greater than or equal to 7. And the question is 7 one of the solutions? And the answer is yes, because g is greater than or equal to 7. And because we have the or equal to part, that tells us that 7 is a part of the solution. If we were graphing this on a number line, that would be a solid dot at our number. And it would be greater than, meaning pointed to the right, shaded to the right from the 7 on the number line. Now let's take a look at examples 2 and 3 and the try it questions that go with them. In each of these examples, we are going to be solving inequalities using either division or multiplication by a negative value. Now, this leads us back to the first question that we explored at the very beginning of this lesson, and that is, what happens to that inequality symbol? Well, remember that negatives are opposites, okay? A negative number is the opposite of its positive value. So when we use that inverse relationship between multiplication and division to isolate the variable in the inequality, just like we do the equation, what actually ends up happening is we end up reversing the inequality symbol. So take a look at the example number 2. Negative 3 4/10 m is less than or equal to 17. This is why checking your answer is so important, because as we divide both sides by that negative 3 4/10, we can easily do the calculations on the calculator. Okay, that's the easy part. But when we do those calculations on the calculator and we find out that m has to be, let's say we say less than or equal to 17 divided by that negative 3 4/10, we get a negative 5 as our answer. We have to check ourselves to say, do those numbers that fit this description work? So I need to take a number that is less than negative 5, not equal to, but less than negative 5, that fits this part of our description, and see if it works. So pick a number that's less than negative 5, such as negative 6. And ask yourself, does that work in this inequality? Well, then the question becomes, what is negative 3 4/10 times a negative 6? And you get 20 4/10. Is 20 4/10 less than or equal to 17? No, it is not. So this does not work. Okay? What that also means is that I forgot to flip my inequality symbol. Actually, the m and the negative 5 are still correct, as is the part of the inequality that says or equal to. But what we need to do is flip that inequality symbol around because we divided by a negative number. So we're going to do the opposite inequality, just like we are reversing that negative symbol in your inequality. So now look for a number that fits the description of m is greater than or equal to negative 5, such as, what if m is 0? Because 0 is greater than negative 5. So is negative 3 4/10 times 0 less than or equal to 17? And the answer is yes. 0 is a number less than 17, so that does work. So when you see the inequality on the graph here, what you should notice is that you have a colored in circle at the negative 5 because we have the or equal to part of our inequality. And then it goes to the right and it is shaded in that direction. So now I'd like for you to complete the 2 try it questions, A and B, that go with example 2. When you're done, come back and check your solution and your graph to make sure that you shade it in the correct direction. All right, go ahead and take a look at the solutions to both parts A and B of the try it that goes with example 2. Notice that on try it A, the x variable is on the right side of that inequality. So as you're solving it, an x remains on the right side, as it does here. So you'll see here's the x variable. Then if you want to flip it around so that you can read that inequality a little bit easier, then the inequality also has to flip around because the greater opening of that inequality is facing the x variable here. And therefore, when you flip the entire inequality around, it still has to face that variable. Notice also that I did do a check by picking a number that fit the solution of x is greater than negative 7 8/10. Okay, we have an open circle there, and one of those solutions that's underneath the red line that I've shaded is a negative 6, so I substituted that over here and checked it, and it does work. When you do part B, the nice part is that the y variable is already on the left side of your inequality. So as you divide by that negative, you will flip your inequality around, and you get y is greater than 19. So you can pick a number greater than 19 to double check your answer, and negative 3 and 25 hundredths. Pick a number greater than 19, such as 20, and check, let's see there, and check to make sure that that is less than negative 61 and 75 hundredths. So you can't see my writing there very easily, but let's check our 3 and 25 hundredths times 20. You do get a negative 65, and negative 65 is less than a negative 61 and 75 hundredths. So that again does check out. Now take a look at example 3 and follow the solution process here. Notice again that when you multiply by a negative value, you again are going to reverse that inequality symbol. Okay, and then when you're done checking out the example, go ahead and take a look at A and B, see if you can solve those, and come back and check your answers. Okay, go ahead and take a look at the solutions for both A and B on the triads. Notice that on A, you do need to switch that inequality because you are multiplying by a negative 5/10. And when I checked my answer, what I did is I selected a number greater than negative 6, so I picked negative 2. And when I solved that, I got 4 is less than 12, which is true, so that solution set works. In part B, you have a fraction in front of that variable, and just like with any fractions, when you're trying to clear them out of an equation or inequality, you have to multiply by that reciprocal relationship. So you'll notice that we flipped around that negative 5/4 and we made it negative 4/5. And then when you multiply that times 25, you get a negative 20. So there's our solution here. And then when I pick a number that is less than or equal to negative 20, I chose negative 40 right here. And after I chose negative 40, I got 50 is greater than or equal to 25, which is again a true statement, so we should be good to go there. All right, check out the next video on the practice work.